Evers, our guest speaker for today. He runs the Eco-Profit Consultancy and has a master's in climate change and sustainable resources management, and has a long history working in the carbon and energy management area. He's been developing and managing leading edge projects to benefit the environment, local communities and business profitability. He specialises in eco-education for businesses and households on subjects such as sustainable development, corporate social responsibility, environmental issues, and behavioural change to mitigate and adapt to climate change. But today he's talking to us about calculating your carbon footprint and identifying ways to reduce and offset it. So welcome, Winton, and over to you to take us for the next half hour.
Thanks, Rod. So I'll just click on the green button here. What I wanted to talk about today was sort of like going back to real basics. It appears to me that a lot of people that don't focus on carbon reduction and carbon footprinting and things like that really don't even understand what the term carbon emission is. And today was more a way of sort of putting the discussion in one place, if I can put it that way, and starting with the calculation of a carbon footprint, and then sort of going through to, well, this is where we start. We've got a baseline here with our carbon footprint. Now what I can do, I've got two choices. I can firstly reduce that carbon footprint as much as I can. And the second thing is whatever's left over, I'm going to try and use carbon offsets or carbon credits as they're called. So I just wanted to touch on that. A lot of it's probably pretty basic for you guys, but probably if there's something you can take away as a message to people that may not be as well versed as you are. The first thing is this term, they use the term global warming and climate change interchangeably all the time. And I just think it's important that people understand the difference there. And global warming is obviously pretty straightforward in the sense that the Earth is heating up on average without greenhouse gases, without the greenhouse gas effect. The Earth would be at minus 19 degrees, but it's on average, but it's at 15 degrees plus on average, which makes life habitable, well, at least our particular species. Climate change is the fallout from that global warming. It's the outcome of all that heating. And, you can look at, we saw over the summer, the fires that are hitting us with the drought conditions and the extra heat waves. We have more floods now, we have more hurricanes. The hurricanes are more intense because there's more energy in the atmosphere. We even have cold spells, especially in America. You see it there because all the jet stream air patterns have changed, letting the cold air out at certain times. We have sea level rise and storm surges, loss of ice generally in the cryosphere and glaciers. We've got species extinction. There's a number of estimates, but I think there's about one extinction of flora or fauna every 10 minutes of the day. You have species invasion. Just the greenkeeper the other day up here, we're in the Blue Mountains, was noticing a species of parrot that he said normally you'd only find from a sort of the Queensland border up, are nesting on the course. So this is all these outcomes that are happening because the globe is warming up. And just in that research I was doing before this presentation, I noticed in terms of the amount of forests, as a bit of an aside, 28 million hectares of forest is being pulled down, burnt down or pulled down each year, which works out to 280,000 square kilometres, which is 767 square kilometres of forest a day. We, as a human species, are eliminating. Not good enough. Now, what I wanted to talk about here is we have the greenhouse gas effect. The largest greenhouse gas by volume is actually water vapor, but in terms of acting as a greenhouse gas, it's not as effective as carbon dioxide, which is the next most prominent greenhouse gas in the atmosphere. So the KYOTO protocol originally had 6 gases: carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, nitrogen trifluoride. Methane comes from obviously from agriculture, cows and animals, and even us, from landfill, and from escape from mining coal and oil and gas. Nitrous oxide, the main source there is from fertilizer use, so something to look at. Hydrofluorocarbons are human-made gases after the Second World War, and they're used in air conditioning and refrigeration systems. Perfluorocarbons used mainly in making aluminium. Sulfur hexafluoride is used by in the electricity grid, mostly in transformers, as a sort of a heat eliminator. And nitrogen trifluoride is used in a lot of electronics. Now, what happens is with these different gases, they all have a different amount of how good they are at trapping heat. And so what they wanted to do is figure out, how can we put all these gases on the same page? How can we have a single metric to measure the whole impact? So what they said is, what we'll do is we'll take 1 ton of carbon dioxide and make it equivalent to 1 ton, what we'll call carbon dioxide equivalent. So 1 ton of carbon dioxide is equal to 1 ton of carbon dioxide equivalent. That will be the base measure. And it is calculated on how good is carbon dioxide at keeping the heat in, which goes to how many, what wavelengths, frequencies, I should say, or same thing, that does the gas accept in terms of infrared radiation, and also the life of the gas in the atmosphere. But I won't go into too much of that technical detail. Suffice to say, 1 ton equals 1 ton. So then we then go to methane. Its global warming potential, which is the term we use, is 25 times more than carbon dioxide. So in other words, if you release 1 ton of methane into the atmosphere, it's equivalent to releasing 25 tons of carbon dioxide. And go to nitrous oxide, that's 298 times. So 1 ton of that goes up there in the atmosphere, that's 298 tons of carbon dioxide equivalent. The hydrofluorocarbons, they're coming in at somewhere between 100 and 3,800, depending on the type. We'll come back to that in a minute. And you can see it gets worse. Sulfur hexafluoride, 23,900. The Americans a couple of years ago went right through, I think it was in California, through their grid and tightened up any leakages of that chemical from their transformers and reduced carbon emissions by millions of tons. Now, if we go to I've prepared a carbon footprint here for Mr. and Mrs. Blogs, and for the 2019 calendar year, just to get an idea of, where's the start? How do I want to figure out what impact I'm having. And once I figure that out, then I can turn around and see what I can do to reduce the impact of my carbon footprint. So if I go quickly up the top here, refrigerant leakage, that's where we talked about the hydrofluorocarbons. That's from your cars, the refrigeration, air conditioning in your cars, air conditioning at home, your fridge, your freezers. So say 20 grams. Because in the case of R410A, which is a very common refrigerant, this works out at there's 2,088 global warming potential. So that tiny little bit, 0.2 of a kilogram, will deliver us 418 kilograms of carbon emissions. CO2e. If we go down to the diesel vehicle here, I've assumed we've got 2 vehicles in the family. The one gets a 70-litre tank, the diesel, and it's filled up every fortnight. Lo and behold, look at that, 5,185 tonnes. If I go to the second vehicle here, unleaded petrol, 50-litre tank, assuming that it's filled up once a week, 6,349 tonnes. Interestingly, if I was to get rid of that vehicle and catch the train, the total carbon emissions and do the same amount of travel, the total carbon emissions would be 300 kilograms. We've got gas there at 8,000 megajoules, which is a pretty common bill for hot water, for cooking and for showers and things. Sorry, for hot water for showers and cooking as well for your stove. 513. Electricity consumption, that's a classic, at about 1,200 kilowatt hours a quarter, gives you 4,320. So if we, and then I've done a number of other types of emissions we may not necessarily see: text, emails, streaming, plastic bottles, booze and coffee, plastic, paper use, toilet paper even, and waste disposal. But if I go down that list, the significant ones are the fuel consumption, the gas, and electricity consumption and wages. So to make it easier for people so they can just get on without having to go, I had to go into the tables, the factors, emissions factors to calculate all of that. If I just have in my head 1 kilowatt hour of electricity is equivalent to 1 kilogram of CO2e carbon emissions, made obviously from the burning of the coal. It has come down actually because of the mix of renewables that have come into the system. But just if you've used 1,000 kilowatt hours of electricity at home, you go, wow, that's 1 ton. You know, that's after you've incorporated all the global warming potential of the different gases that were emitted during the generation of electricity. The same thing with petrol, like out of the tailpipe comes a bit of nitrous oxide, methane, but mostly carbon dioxide. But when you juggle all the formula in, it works out to about 2.4 kilograms of CO2e for every litre you burn on your car. Your diesel, 2.9. Gas, so if you look at your gas bill, just think that every 16 megajoules is another kilogram CO2e. And your waste, municipal waste comes in at about 1.4 tonnes. And so I made here, just assume 20 kilograms a week in weight to get right at that figure there over on the side. Boy, how am I going for time? So if we now look at the formula to be carbon neutral. So in other words, what I'm going to do is I'm going to look for opportunities if on calculations with EV, electric vehicles. It's going to make such a huge difference. And even if you're using coal-fired powered electricity, you're still going to reduce emissions by 40%. But ideally, with a at-home solar system, and when battery prices, like the Powerwall's about $900 per kilowatt hour stored, but once it comes down to about 500 kilowatt hours, $500 per kilowatt hour stored energy, you're looking at about 25% return on your money. And you know, if you go and put money in the bank, you're lucky if you get 0.5% these days. So it's a really good deal. Solar is already a really good deal for investing your money in terms of internal rate of return. It can be anywhere between 30 and 50% return. So looking at ways that, one, energy efficiency, in terms of vehicles, what other modes of transport can I use, or what other style of car, i.e. EVs. Energy consumption, this is where, you know, I have a whole range. I break up homes into heating, cooling, appliances, lighting, and hot water. There's a whole range of things you can do, starting with passive cooling and heating of your home itself, so that you don't have to pay to either shovel heat in or shovel heat out. But every kilowatt hour you save, just know you've saved a kilogram in CO2e carbon emissions. And of course, with solar, then you're going to eliminate it all. There is, you know, except for maybe one panel, it's going to take about, 5 years for one panel. It would take about 5 years. So when you make a solar system, the actual system probably has embedded carbon emissions equivalent to about one panel out of 10 sort of thing, but that's quickly pays itself back. Waste is obviously something you want to reduce as well, in terms of what can we do with our food waste, especially in composting and improving the soils and things like that. But so we've looked at the carbon footprint. we established what it was. We went in, we went through the options to decrease those significant items. And then we said, righto, what we got left, we can't reduce any further at the moment. So we're going to go to this formula. Carbon neutral, I want to be carbon neutral, is equal to carbon emissions minus carbon offsets. We now know our carbon offsets. A carbon offset is equivalent to 1 tonne of CO2e taken out of the atmosphere. Or it can be an activity where there definitely would have been more carbon emissions from another activity, but because you put resources, financial resources, to changing the way that activity is undertaken, you've actually eliminated those emissions. So you can have carbon offsets in so basically 2 ways. And as I say, measured as the equivalent of 1 tonne of CO2e coming back the other way. They're very quickly, sorry, Rod, if I'm running out of time here. Offsets are either compulsory or voluntary. We sell carbon offsets connected to the Clean Development Mechanism, which is United Nations Fund, which I won't go into too much detail because of the time constraints, but there's an example of one of their programs in India. So it's a program to set up carbon emission reduction programs in what's called developing countries around the world. So in summary, what we want to do is calculate a carbon footprint, work out what we can do to minimize it, recalculate the carbon footprint after changes, select the offset program you favor, and go from there, acquire the number of offsets equal to carbon emissions. Just at the end here, I'll just quickly say that in terms of our carbon offset program, we've introduced something unique. And the thing is, when you buy carbon offsets, it's to do with some activity on the other side of the earth, spatially a long way away. So we've introduced every carbon offset we sell now, $1 donated to our not-for-profit. And that goes to putting solar on the roofs of not-for-profits in the local community. The photo down on the left is a photo of Earth Recovery, which the roof of Earth Recovery, that particular building is a place where homeless people can come and launder their clothes and wash themselves and just have social interaction with other humans. They also feed the Earth Recovery, feed the homeless. So we use the money from selling carbon offsets to businesses at $1 an offset to put that 5 kilowatt system on the roof. And the photo up on the right-hand side is the project we're involved in at the moment called Gateway. They look after families that are struggling emotionally, financially, and they're being smashed at the moment. So we're trying to get a 7 kilowatt solar system up there, and if we get a community-based community-based partnership grant approved, I'll throw a Powerwall in on that one as well. So yeah, so there's a lot of things we can do. We can cut our carbon emissions right down, and then we can go to offsetting programs and find ourselves either carbon neutral, and if you're really keen, you can go carbon positive, which is buying more offsets than what carbon emission base is. Is that Rod? Hello? Hello?
Hello, Winton. Thank you for that. And sorry, my internet played up for a second there. So,
am I way over time? No, I'm not.
No, you've done really well. You've been
Yeah.
spot on. Congratulations and thank you very much. And I loved how practical and useful at a personal level your presentation was, as well as taking in the much broader national and global implications. So I much appreciate that. And I'd like to make the first question, and that is simply to ask, what difference would a carbon price make to individuals like us trying to deal with our carbon footprints?
Well, that's the carbon pricing mechanism that was brought in 2012, 2013, and then Abbott got rid of, was having a marvelous effect. You know, carbon emissions were coming right down. And guess what? No one even noticed. No one said, oh, geez, all the prices have gone up. And on the other side of the coin, what the government at the time did, which was really good, from the money they collected from the gas. So just to go back a step, we have a plan called NGES, National Greenhouse Gas Emissions Reduction, and it's a monitor of all the major gas emissions companies in Australia. So they know so much about who's doing what, where their carbon emissions are coming from. They adapted that and put it into the carbon pricing mechanism, and then they said, right, we're going to charge, you'll start off at $23.15 per CO2e for these major emitters who emitted more than 25,000 tonnes of carbon emissions each year. And then, of course, our bills went up, our food went up slightly, our electricity bills went up by, you know, about a cent a kilowatt hour. No one even noticed. And in the meantime, the carbon emissions are coming down. Then on the other side, the money they collected from the tax, which it wasn't a tax, it was a carbon price, the money that they collected, they put half towards allowing the tax threshold to increase from $6,000 to $18,200, and they took half and put it towards these various grant energy programs for companies. And I was involved in some of those. So these companies then had the chance to get beyond that capital hurdle, which is often the problem. And they were applying for grants, and we're seeing so much innovation in energy efficiency, in renewables. You know, it was just a completely changed dynamic, you know, the way companies were thinking. So there was underlying it all was this positive move. And then, of course, the tax got taken away. Did anyone notice? Did our electricity bills, anyone notice our electricity bills went down? No. Did anyone notice the food went down? No. And all that happened was the carbon emissions went up, which is what the current government is relying on. That dip is what saved them and gave them some credits that they can now helps to offset the target they're supposedly meant to be meeting. So yes, I think very highly of it. I really like the idea that, you know, it's one of those things that's difficult to sell to the electorate because maybe misunderstanding or whatever, because it can be scuttled by the opposition politicians, anti-climate denying people. But if there is an obvious reward to people, you know, that they will get something out of it, I think that's a good idea, which is, I think, what your plan is, isn't it? With the fee.
Dividend is a very
Dividends,
very monthly reminder to people that the carbon fee is benefiting them to some extent or other. So yeah, thanks for that point. We've got time for a couple of questions. Anyone want to? Peter Todd, go for it.
Winton, just one on electricity. If you're looking at your electricity bill and you think you'd love to reduce it, what's typically the easiest ways to find ways to reduce your electricity bill?
Passive cooling and heating. You know, like if you can, you know, I've done about 400 home assessments, and I can't believe how many times I've been to a house and there's a draft coming straight in under the door. I'm sitting right in it. So I'd have snakes and things like that. Put that in there. There's 25% of heat loss just there, with, you know, and you can get those door seals and things like that. Taking steps to stop the heat getting out in winter, and in summer times, taking steps to stop it getting in, you know, like if the sun, I don't know how many times I've been into rooms facing to the west with children's bassinets in them, you know, with the sun beaming in, you know. So, you know, you can use the reflective curtains, but ideally, you know, if you've got a deciduous tree, so you can get the winter sun, the warmth of that, or, you know, some sort of shelter, you know, against the sun hitting the window. You can, you know, in some cases, because it was a low energy program, people were really struggling financially. So one place I just got some foil and put it up in the window, you know, just to reflect the heat away, you know. So things like that, shading, you know, there's basically, if you go back to they have basic categories like house orientation, obviously facing to the north and da da da, and then you've got thermal mass, and you've got shading, and then your windows. So the 4 mil windows. So he's just rushing through there. If you can stop that, even just putting the curtains across, either the heat coming in or going out with a pelmet at the top, that will help tremendously in, you know, keeping heat either in or keeping it out. Simple things like that. I mean,
Thanks,
I've got a whole list of things there that I could send to you, Pete, if you wanted, you know. But
Marie has a question.
yes.
Thanks, Winton. So when I heard Christina Figueres talk at WOME Adelaide last week, I just wanted to hear your thoughts on this. She just suggested that we all do the same thing to figure out what our carbon footprint currently is, and then go for halving it by 2030. And then go for zero by 2050. She said you tend to overestimate what you can do in the first couple of years, but underestimate what you can do sort of longer term. So I wanted to hear your thoughts on that. Also wanted to know, I didn't see anything about your diet and what kind of diet you have in there, you know, meat versus vegetarian. And also, is there a good online calculator that you can use? For all
For
of
your
this?
carbon footprint, yes, there are a number of calculators, but just go back to that first point. That's why I put the rule of thumbs in there. Like, you know, 1 kilowatt hour of electricity is 1 kilogram of CO2e, because then you can say, oh, well, look, if I can save that somehow, or especially with the car, when you look, and if you take that footprint and you see the different percentages and how much fuel is as a part of the whole thing, that then gives you the clarity to say, well, look, I could walk to the shops, you know, or it gives you the information to say, well, if I really want to save, this is how much I'll save if I walk there, or I catch the train there, which is about 8.5 grams per kilometre, which is, you know, it's a tiny amount compared to what you do with your car. So in other words, so there's more information about that. There are a number of sites on the web about, you know, where you can look up your carbon footprint, and you just put in how many kilowatt hours you use in flights and this and that, and that can tell you the footprint. But yeah, and that where I got that information, they've already sort of got all those formula calibrated in those plans, so you can do that quite easily. I wanted today, though, for people to realise a little bit more where that's coming from, and to go to the food thing. When you do a carbon footprint, there are certain rules under the National Carbon Offset Standard and things like that. And you'll know, I forgot to mention, there was scope 1, 2, and 3 carbon emissions. Scope 1 is you direct control over gas, fuel in your car, you know, you making the decision. And electricity has its own scope, but it's basically could be a scope 1. It's just because there was going to be so much, they made it its own scope. Scope 3 carbon emissions is all the carbon emissions upstream to get to, whether it's food or packaging or anything manufactured from China, from here, from there, and it is all the carbon emissions downstream, and that's waste. So if I were to take an analogy of a bakery, there it is in the middle. It has its own gas consumption and electricity, but then it has all the carbon emissions upstream, from the growing the wheat to it being to the flour mill, the transport, the packaging that comes that they're going to then sell, and then down the customer coming to the shop to get the food, and the car emissions there, the carbon emission in the car, the waste and everything else. So it's a whole thing. So you have to, if you took the whole, it's called a life cycle, and if you take the whole lot, you're in a whole new ball game. And this is where we get to the food thing. And the one part, a very complicated area, but one part's for sure, the methane emissions have been approximately a third from the animals, a third from the landfills, and a third from the coal seam, you know, fugitive emissions. If we stop mining there, we can get rid of them. With the landfill methane, which has got a 25 tonnes of CO2e equivalent, like 1 tonne of it's 25 tonnes. If we flare the methane at the, and I won't go into the chemistry, but if we flare the methane there, we reduce 1 tonne of methane or 25 tonnes of CO2e to the equivalent of 2.75 tonnes of carbon dioxide. And if we could take that heat and make electricity out of it, we'll be in front. You know what I mean? Now, to go to the food, what's the problem now is that the proportion of methane from animals is on the rise. And at the same time, as I mentioned earlier, there's 767 square kilometres of forest being pulled down every day, and a lot of it is to accommodate these animals. So there has to be a huge change in terms from the carbon emission perspective in that alone. A very complicated area. You then get down to, you know, how much land area do you need for growing soy and blah, blah, blah as well, and biofuels and things like that. So it's, I don't know if I've answered your question, but it's a complicated area, and we definitely need to cut back on the meat intake, significantly.
Thank you for that, Winton. We have time for one more question, and Emma Story has an electronic hand up, so I'm going to reward the electronic hand and invite you to ask your question, Emma.
Yeah.
I was just wondering about, there's a green power, like Australian government scheme for purchasing your home electricity from renewables. Do you know about that, and do you think it's a good scheme and a legitimate way of reducing your home electricity CO2?
Yeah, it is. It supports the renewables industry. What happens is, have you heard about those renewable energy certificates? And we have the RET target, renewable energy target, which runs out this year, and which the government is not extending. They're sort of leaving it in place, but they're not setting a new target. That program is the reason why the Liberal Party can even say we're going to make the target at all. Because under that program, the retailers, electricity retailers, had to buy a percentage of their electricity as renewables. And they did it by setting up a thing called the Renewable Energy Certificate Program, which is where, say you've got a wind farm or a solar farm, you say, we're going to make 100,000 megawatt hours of electricity. That's a megawatt hour is 1,000 kilowatt hours. We're going to make 100,000 megawatt hours of electricity a year. So a REC certificate is equivalent to 1 megawatt hour. So they said, righto, you can raise 100,000 megawatt hours per year and put it on the REC registry, and the retailers who are obliged by now getting up to 20%, well, it never got that high, but say 15% of their electricity had to be backed by them buying these renewable energy certificates. So when they bought those certificates, the money went to those various renewable setups. When you buy green energy, all they do is they go back and buy more RECs at that registry. So it does work, more money does go to renewables. And so you're not throwing your money away, except to say this, that when you calculate the costs of green energy, and then you go back and you have a look how much a REC's selling for, you'll often find you're paying twice as much. But anyway, other than that, so you can just go and register and buy a REC yourself, or to the number of amount of electricity you've used, which, bearing in mind they're a megawatt hour each, so one would cover a lot of ground.
How do you do that?
You go onto the renewable energy registry, and you have to register. And I knew you were going to ask me that.
That buys them. Yeah.
Yeah, but you can. People individually can buy the RECs.
Right.
and you'll save some money. But the only trouble is you wouldn't have gone through a megawatt hour of electricity, possibly. I don't know. It depends. Oh, well, you could have,
Yeah.
1,000 kilo, could have done 4
Does
or
it have to
5.
be per year, or can you buy one
Per
for
year,
several
yeah.
years?
It's
Right.
as you use the electricity. You could do it each quarter or each month whenever you get your electricity bills. And you'll find it. So I think they're about $36 at the moment. But if you go to your bill and you did the maths, and you say you bought 1,000 kilowatt hours of green energy, you probably find, it's up in the 70s. It's another little way to make a quid.
Cool. Thank you.
Thank you for your question, Emma, and thank you, Winton. And that's all we have time for in terms of questions, but I'd just like to thank you again for what you've presented to us. And it's also good to know that you're part of Peter's CCL group, so you're actually one of us as well as our guest speaker today. So especially a warm welcome to you and a big thank you. So thanks very much.
Oh, thank you very much for that. Thank you.